Hi, hello, this is Gopal. Welcome to Physics Rank Guru. Today we are going to discuss rotation of inertia, momentum of inertia. Rotation of inertia, also called momentum of inertia, it is represented by a letter I. Okay, na? What is momentum of inertia? So it is a property of a body due to which it opposes any change in state of rest or state of uniform rotation. This is called what? Moment of inertia. So it is the property of a body due to which it opposes any change in its state of rest or state of uniform rotation. Is called what? MOI, momentum of inertia. So here momentum of inertia short form is MOI. So MOI plays the same role. Momentum of inertia plays the same role motion in rotational motion as mass plays MOIs plays same role in rotational motion as mass plays in translational motion. Okay na? So here you can take for a particle of a mass m. So this is the axis of rotation. This is axis of rotation. So here I will consider the mass m. From axis of rotation to this is the distance is r. So what is the momentum of inertia here? I is equal to mr square. So here r always perpendicular to the axis of rotation. So what is mass of m is mass of the particle, I is moment of inertia, r is equal to perpendicular distance from axis of rotation is r. So r is perpendicular distance from axis of rotation. For a particle of mass m rotating about a fixed axis, particle of mass m rotating about a fixed axis from a distance is r, what is moment of inertia is equal to I is equal to mr square. Right? So MOI of a group of system of particles, this is the axis of rotation. From the axis of rotation to I will consider this is the mass m1 and this is mass m2, this is mass m3, this is mass mn, this is mass m4. So from m1 distances I will consider r1. So from m2 distance I will consider r2. From mn distance I will consider rn. For m3 distance from axis of rotation to r3. From m4 distance I will consider r4. So what is the momentum, total momentum of inertia? I is equal to I1 plus I2 plus I3 plus I4 dash 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 IN. So I can write I is equal to m1 r1 square plus m2 r2 square plus m3 r3 square dash 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 mn Rn square. So this is the momentum of inertia of a system of particles, group of system of particles. I is equal to I1 plus I2 plus I3 plus I4 dash dash In. I is equal to M1 R1, M1 R1 square, M2 R2 square, M3 R3 square, M4 R4 square dash 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 Mn Rn square. So can I write this one? So I is equal to summation of M R square. So this is the formula for group of system of particles. So what is SI unit of MOI? So SI unit is SI unit is equal to, for we can measure mass is kg and distance is meter square, kg per meter square. This is the SI unit of MOI, momentum of inertia. It is a scalar physical quantity. It is a scalar physical quantity. So this is the group of system of particles. For single particle, momentum of inertia I is equal to mr square. For group of system of particles, I is equal to summation of mr square. So SI unit is kg per meter square. It is a scalar physical quantity. So next MOI depend upon MOI moment of inertia depends on MOI depends on first one, mass of the body. MOI depend upon mass of the body. Second, distribution of mass of the body. Distribution of mass of the body. Third one, position of axis of rotation. Position of axis of rotation. Next, square of distance from axis. So MOI depends on mass of the body, distribution of mass of the body, position of axis of rotation, square of distance from the axis. So it is independent on MOI. MOI is independent on or does not depend on angular velocity of the body. Angular velocity of the body. Angular velocity of the body. And MOI independent of angle. MOI independent on angle also. So for rigid body, MOI I is equal to mk square. K stands for radius of gyration. K stands for radius of gyration. Radius of gyration. So here K is equal to, we can write I by m under root. So this is the radius of gyration formula. Depend upon K. Radius of gyration depends on depend upon distribution of mass of the body. K depend upon distribution of mass of the body. Position of axis of rotation. Position of axis of rotation, position of axis of rotation. So here K independent on K independent K independent on mass of the rotating rigid body, rotating rigid body. So find MOI of a system of three identical particles lying on an equatorial triangle. So which is perpendicular to AB and passes through its center. So I will consider three equatorial triangles. So this is point A, this one is B, this one is C. So here which is perpendicular to AB and passes through its center. So which is perpendicular to this axis is passes through, okay na, perpendicular to AB and passes through its center. So you can find out the MOI. So this is each side of length equatorial triangle, no, each side I will consider L. Each side consider L. So this is the total length is L. What about this distance? L by 2. So this distance is what? L by 2. So you can find out the MOI. So here MOI is equal to, so here I passes through the C, so this is 0. So here you can consider, so from this mass to, so this is mass, identical mass, so this is mass M, this is mass M, this is mass M. So MOI is equal to IA plus IB plus IC. So here IA is equal to, from axis to perpendicular distance is L by 2. From B also, from axis to perpendicular distance is L by 2. So C is exactly passes through the center, so this is 0. So can I write M L by 2 whole square plus M L by 2 whole square plus M into 0. So here M L square by 4 plus M L square by 4. So what is the total I? I is equal to 2M L square by 4. 2 1 ja, 2 2 ja. So what is MOI? I is equal to M L square by 2. So in case which is perpendicular to AB and passes through its center. So I is equal to ML square by 2. I is equal to ML square by 2. And here you can change in the plane of ABC. In the plane of ABC. So second one, which is perpendicular to AB and in the plane of ABC. Now this axis is passes through, okay na. So here which is perpendicular to AB and it's a plane of ABC. So this is the axis of rotation now. This is the axis. You can find out the three masses are there, three identical masses are there. This is point C. So here I is equal to I1 plus I2 plus I3, I1 plus I2 plus I3. So this is from A. So here perpendicular B point perpendicular distance is, so here A is equal to 0. Momentum of inertia of particle IA plus IB plus IC, you can find out first. So here IA is equal to 0, mass into perpendicular distance is 0 here, plus I mass, here perpendicular distance is total L, so total L you can consider. From axis of rotation to B, how much distance is there? L distance is there, that's why ML square plus, so here you can distance, this distance you can find out. So here this is the equilateral triangle, this angle is 60. So I will consider this is one axis, I will consider this is also 60. So this is L means, so makes an angle with the theta. So this is what L cos theta. L cos theta is equal to L cos 60. L cos 60 value is what, L by 2. So this distance is from C, perpendicular distance is what, L by 2. From C particle, perpendicular distance is what, L by 2. So here M, L by 2 whole square. So this distance, already here distance here exactly passes through AB. This also L by 2, this also L by 2 distance. Before only you can calculate it here. So this distance is 0. This distance for axis passes through A, this distance is perpendicular distance is 0. For B particle L, for C particle is L by 2. So L by 2. Then simplify this one, ML square plus ML square by 4. So simplify it. So 4 ml square plus ml square by 4. So this is what, 5 ml square by 4. So this is the momentum of inertia which is perpendicular to AB in the plane of ABC. In the plane of ABC. This is moment of inertia. So next one you can discuss. So next see. So MOI which is passes any one of the side. Any one of the side. So this is equilateral triangle. So identical masses are there here. M, this is M, this is M, this is M. Now axis of rotation passes through any one axis. So this is axis of rotation. So this is the axis now. So now you can find out I here. So momentum, this is point A, this is B, this one is C. So here momentum of inertia for A particle is 0, for B particle also 0. For you can find out C particle. So this you can find out the perpendicular distance. You can find out perpendicular distance. So here this is total angle is, this one is 60. So this off angle is here to here, that is angle 30. So this is L, this is side L. So what about this one? This is L cos 30. L cos 30, this distance. So here perpendicular distance is equal to L cos 30. Distance R perpendicular is equal to L cos 30. So L cos 30 value root 3 by 2. Here you can write. So IA, IB, IC. IA is equal to 0. Exactly passes through this A. So 0, M into 0. So here B, for B, M into 0. For C particle, so M, here distance is perpendicular distance is L root 3 by 2 whole square. So here M, L, root 3 value is 3 by 4, ml square. So 3ml square by 4. So this is the momentum of inertia which is passes any one of the side. Which is passes any one of the side. So this is the momentum of inertia 3ml square by 4. So if axis passes through centroid and perpendicular to plane of ABC, first you can draw this is equatorial triangle of a side L, of a side each one is L. So this is the centroid, axis is passes through like that, exactly centroid. So this is identical particle is mass M. So this identical particle is mass M. So this is mass M. So first you can find out, so what is the perpendicular distance? So this is the axis, you can find out. So from this axis to perpendicular distance of A, so this is the point A, this is B, this one is C. you can find out. So this is the axis now. So this is the, what is the perpendicular distance from A to this axis, from C to this axis, from B to this axis. You can find out this distance. You can find out this distance. So this is what this total angle is 60. So what about this angle? This angle is 30. So this distance you can find out. So I want this is x. I will consider this is x. You can find out x. So this is from centroid to this distance. So this is L, means from centroid this is L by 2. So this distance is L by 2. So L makes an angle with the 30. What about along the 30? So this is the triangle. Here triangle is formed. Here triangle. So triangle can I write? So cos theta is equal to cos 30. Cos 30 is equal to adjacent by hypotenuse. Adjacent by hypotenuse. So here adjacent is equal to L by 2. By hypotenuse is x. I want x. So x is equal to L by 2 of cos 30. So can I write this one? L by 2 cos 30 value root 3 by 2. This 2 cancel. So x is equal to L by root 3. So you can find out now I, moment of inertia, I is equal to IA plus IB plus IC. So here IA is equal to this mass into this perpendicular distance is what? L by root 3, m L by root 3 whole square. So similarly like that, m L by root 3 whole square, m L by root 3 whole square. So this is equal to m L square by 3 plus m L square by 3 plus m L square by 3. So can I write this one? 3 times is there. 3m L square by 3. This 3 can, I is equal to m L square. So this is the total MOI. I is equal to ML. So find MOI about an axis which is passes through one of the mass and perpendicular to xy plane. So first you can draw the equatorial triangle. Equatorial triangle. So this is side is L. This is the identical masses M, M, M. Identical masses. So now here given find about MOI, which axis which is passes through one of the mass and perpendicular to xy plane. Means now axis is passes through like that. Axis is passes through like that. So you can find out this is the MOI. So this is the axis. This is axis. About this axis you can find out that axis is perpendicular to xy plane. Perpendicular to xy plane. So this is point A, B and C. So here you can consider I is equal to IA plus IB plus IC. You can find out. So here IA is equal to 0. So m into 0. Here perpendicular distance is 0. For B particle m. So what is the perpendicular distance about this axis to this perpendicular distance is L. So ml square plus this axis to this is the perpendicular distance ml square. So here I is equal to 0, ml square plus ml square 2ml square, 2ml square. So this is the MOI of perpendicular to xy plane. Perpendicular to xy plane. Listen. So please like, comment and share my videos. So regularly watch my videos and please comment. So don't forget subscribe Physics Rank Guru. So all of you bye. Take care. Have a nice day.